Hi everybody, we are going to continue our discussion in this example, cost, volume, profit analysis. This time we are going to look at multiple products. In the previous example it was kind of easy because we were looking at one product. It had one sales price and it had one variable cost. Let's examine what's going to happen when we have two products. In this example, we are selling 400 units from product A and 600 units for product B. Sales price for each product per unit is given. We also know the total variable cost for each unit. Last, we also know the total fixed cost for the company. Now, assuming sales mix is going to stay the same, we need to calculate the break-even point in units. Again, with multiple products, the challenge is which sales unit am I going to take and which contribution margin am I going to take. For that, we need to introduce a concept where we are going to take the two products or multiple products, it can be 3 or 4, and we are kind of going to reduce that into as if it's a single product. This is called weighted average contribution margin. What we are going to do is, with the two product example, we are going to calculate the contribution margin first, which is unit sales price minus unit variable cost. Contribution margin for B is pretty much the same. Unit sales cost, the price, minus the variable cost. Now, it says assuming sales mix is going to stay the same. What that means is total number of units we are selling is actually 1,000, 400 plus 600, right? So product A essentially is 40% of sales, of our total sales, and product B is 60% of our total sales. Now, the weighted average contribution margin, basically what it does is, okay, 40% of my sales is going to have a contribution margin of 500 right here, and 60% will have a contribution margin of 1,500, and my weighted average contribution margin, quote unquote, is $1,100. What that means is, now we could easily have one product with a contribution margin of $1,100 and then look at these fixed costs and calculate what the break-even units is. That's exactly what we are going to do, and we are going to say, okay, I'm going to divide this fixed costs by weighted average contribution margin. It's this one here. I would divide it by contribution margin if it was one product. Now I'm treating these two products as if they are one product with the following contribution margin. And what I'm saying is the fixed cost divided by the contribution margin, weighted average, is going to be 1,000 products. In other terms, I need to sell 400 units of product A, 40 times the 1,000 right here, and 600 units of product B, 60% multiplied by 1,000, in order to break even. You can do the math. You can basically say, okay, 400 times 400 plus 600 times 600 minus 400 times 2,500 minus 600 times 3,000 minus the fixed cost is going to give me 0. Not sales units, it's sales price. So it is, one more time, 400 times 3,000 plus 600 times 4,500 minus 400 times 2,500 minus 600 times 3,000 minus the fixed cost 1.1 million is going to give me 0, which is the break even. Assuming the sales mix is going to stay the same, calculate the annual break even point in terms of dollars. So let's do that. I need to produce 400 units of product A, or sell, and 600 units of product B. 400 times 3,000, 600 times 4,500. 3.9 million is actually going to be my break-even sales. And again, you can subtract the variable cost and subtract the fixed cost. You are going to see that the profit is 0, which is the break-even point. What we did with this is for the idea behind weighted average contribution margin is if you have multiple products, we need to divide fixed cost by contribution margin, and each product will have a different contribution margin. So weighted average contribution margin will give us a tool where we reduce multiple products as if they are one, and then recalculate the number of units based on the percent split of sales.